So, to begin with, what is a quadratic? Y equals x squared was your simplest quadratic. And of course, they get more complicated from there. If I say it's y equals x squared plus x, is it still a quadratic? Yep, because its biggest power is 2. If I added plus x to the 7th, then it's not a quadratic anymore. The biggest power has to be a 2. All right, and what are the zeros of that quadratic? Yes?
Just 0.
Okay, not bad, but there's more than that.
0 from 0.
That's not a bad start. Okay, everybody, solve this quadratic. You're like, what do you mean solve it? Solve it. Find the solutions. There's 4 names for them. Solutions, what else is another name for them?
Zeros.
Zeros, what's another name for the solutions? What? Roots. Write these down. Zeros, roots, solutions, and then one more thing which apparently nobody knows.
X-intercepts.
Oh, x-intercepts. Zeros, roots, solutions, x-intercepts. Write them down. It'll help you remember them. Since I bet you most of you would only got one of them right.
It's like not loaded. I don't know.
Okay, shut all the way down completely. Both buttons. You probably haven't put your iPad to bed for a week. When's the last time you turned it off?
Like shut down?
Yeah, all the way.
It died yesterday.
Okay. I'm not sure if dying counts. Actually, honestly, I don't know. It might do a reboot, but it might not. Just shut it all the way off, turn it all the way back on again. All right, so, and I am curious, how many of you actually knew how to solve this thing? Well, they're called the zeros because you set it equal to 0. How many of you already had that? You had set it equal to 0. About a half of you. Okay, good. From there, if there's a whole bunch of people stuck in here, what is the answer usually? If you can factor it, you should. How many of you noticed that you could factor an x out? Raise your hand if you found that. Oh my gosh, 2 kids. How many times does this have to happen before you start thinking about factoring it? You know what I mean? I'm amazed every year. I can tell you ahead of time, by the way, guys, the answer is going to be factoring. And nobody thinks of it. All right, so what? 0 equals that. So then, Taddy, what's the answers? There's 2 of them. Yes, x equals 0, x equals -1. And what are those things? There's 4 names for them. Name all 4.
Zeros, roots, solutions, x-intercepts.
You got it. Zeros, the roots, the solutions, and the x-intercepts. So if I said to graph it, would you be able to?
Yeah.
Should be able to. You got the x-intercepts for Pete's sakes. 0 and -1. Everybody make a quick sketch right now. Now, what if you had gone completely brain dead and you're like, I don't know what it looks like? XY chart, best friend in graphing. You could find a few points on it. Like you stick in 1, and what do you get? 1 squared plus 1, which is 2. 1 comma 2 is on the graph. And eventually you'd figure out, oh yeah, it's a parabola. Of course it's a parabola. It's going like that. Raise your hand if you had a parabola. Okay, cool. So, common things to forget. Number 1, that if you can factor it, you should. Number 2, you got to set them equal to 0. This. And that finds the x-intercepts because the x-intercepts are where y equals 0. See how we turned the y into a 0? Does that make sense to you? X-intercepts, y equals 0. Let's put a 0 there. All right, so you set it equal to 0, you factor it. What if you can't factor it? Then you can use the quadratic formula. Do you get that big long x equals -b plus or minus square root b squared minus 4ac all over 2a? Would have still worked here. It would have worked. It would have given us the same 2 answers, 0 and -1, but it'd be a lot harder because the quadratic formula got 16 parts. And you got to plug in all those numbers and simplify it down, and it still ends up being this. So that's why I say if you can factor it, you should, because once you got it factored, answers are easy. Do they all factor? Of course not. But the ones we do factor most of the time, and I'd say most of the time on the ACT they want it to factor. Again, to test if kids understand how to factor. Okay, so now, hardest thing. Where's that? Anybody know the name of it? That spot at the bottom where it makes the turn? You, sir.
Vertex.
The vertex. The vertex. Anybody know the formula for that? Okay, I'd say the number one most forgotten formula of the formulas that are useful. There's a lot of formulas for math, but you don't use them that often. This one's pretty handy. You remember it?
Is it the parentheses and then is it, so like y equals parenthesis x
Nope.
uh,
I think you'll see. I think you'll see when I'm done that that's not the one. All right, I'm gonna do the quadratic formula. You know why? Because the vertex formula is part of the quadratic formula. So everybody write out the whole quadratic formula. X equals negative b plus or minus square root. And make the b squared minus 4ac some other color. I have a reason for that. All over 2a. Now, can you write on that, bitch? It looks like it's starting to work. Okay, copy that formula down. It's really important. Because the lesson for today has two important parts. And instead of making you guess again, since nobody knew it, x equals negative b over 2a is the part of the quadratic formula that gives you the x of the vertex and the axis of symmetry. Make notes. Do you get the axis of symmetry is that dotted line that runs down the middle of every parabola? You know what I mean? Every parabola's got one. Dot, 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 dot. Runs right down the middle. That's called the axis of symmetry. And guess what? The vertex on it. And the vertex is on it such that the x of it is negative b over 2a. So here's our formula again. Y equals 1x squared plus 1x. Why are you putting the ones in front, Mr. Server? Because they must be important all of a sudden. That's A, that's B, and that's C. 1, 1, and 0 are the A, B, and C. Okay, next. Let's find this guy right here, his vertex. So I go x equals negative b over 2a. So what is the negative b? Negative 1 over 2a. 2 times 1. What's that? Come on, simplify it. What is it? Negative 1/2. There we go. X equals negative 1/2. What's that? It's the dotted line that runs down the middle. But to get a vertex, doesn't it need two parts? Doesn't it need the x and the y? We just figured out the x, negative 1/2. How are we going to figure out the y? Yes? Plug this into the equation. Very good. Now, I don't know if you can see it. I'm going to make it really obvious by putting a blue negative there, because my black negative sort of blended in with the fraction bar there. Negative 1/2. So let's put the negative 1/2 into the equation. Which equation? Doesn't matter. I personally like to put the negative 1/2 in here. I can do this part in my head pretty easy. What's negative 1/2 plus 1? Isn't it? Yeah, it is positive 1/2. Very good. And then I'm going to take my positive 1/2 times my negative 1/2. Negative a half times a half. What's half of a half? A quarter. And it's negative, so it's negative 1/4. I just found my vertex. That went kind of fast. What'd I do? I stuck that in the equation. Stick the x in the equation. And you figure out what the y must be. Okay. I'm going to give you another simple quadratic. And I'm going to ask you to figure out the vertex of it and the axis of symmetry of it and the x-intercepts of it. Wait a minute, x-intercepts? Is that the same as zeros? Yep. Is that the same as the answers? Yep. Is it the same as the roots? Yep, same thing. Okay, so let's see if you've learned anything. Oh, one more thing. You know that b squared minus 4ac part? That part's special because it's called the discriminant. The discriminant. Do you get if that part right there was negative, that the whole answer can't be real? Because you got the square root of a negative. That's the easiest thing that tells us. Is sometimes if that comes out negative, b squared minus 4ac, then there's no answer. Do you get, if you are doing the quadratic formula, doing that first is smart because at that moment, if you ever get a negative, you can just stop and say, no solutions. See what I mean? So if you're going to do the quadratic formula, start with that. And then if it's ever negative, you're done. What if it isn't negative? Well, then it's positive and you're going to get two answers because there's a plus and a minus 8. And last but not least, if it comes out to 0, if this blue part here comes out to 0, do you get adding 0 or subtracting 0 is kind of useless? Doesn't even do anything. So there's three things that can happen with the blue thing. It can be positive, and you get two answers. It can be negative, and you won't get any answers. Or it could be 0, and then it's like it isn't even there. And then what's left? This formula. Because if this part's all 0, to get the rest of it's, you're adding or subtracting 0 from it, you're just getting the vertex again. All right, I just explained the whole lesson for today, but I think some of it went a little too fast and went over your heads. But tell me this much. If I give you a quadratic, that's a quadratic, even though it doesn't have a squared in it? Yeah, because if I multiplied it out, it would have a squared in it. Everybody go ahead and multiply it out. You know why? Because you're going to need the A and the B and the C to be able to use a quadratic formula on it. And this is a sneaky way of me making the problem. Do you get why it was smart to do it this way, as opposed to just kind of picking random numbers for A, B, and C? What'll this make sure happens? By choosing x plus 2 and x plus 4, I made sure of a couple things. Instead of just slapping out x squared plus 6x minus 12, I know this is special. Because this one factored. Do you get not everything? If I just picked random numbers for A, B, and C, it wouldn't necessarily have factored. And this way it factors, and it gives me nice, clean, what? What does it give me? 4 things. It's got solutions, x-intercepts, zeros, roots. Okay, so I know the 2 roots right away. Do you know the 2 roots right away? So here's the things you should be able to answer from this. You should be able to tell me what A is. I don't know what A is. We'll multiply it out, and you'll know what A is. What B is, and what C is. You also should know what the roots are. You should also be able to do the vertex, because that's negative b over 2a, comma, see if you can handle this, you stick it in the function, it becomes f of negative b over 2a. So I even give you the little formula there to remind you how to figure out the vertex. Okay. What's the first thing you should do? Any volunteers? I already mentioned it. I already said it out loud, but I just not repeating it. What's the first thing you should do? And I don't care about the order. Like, what's a thing you could do? Yes.
Identify A, B, and C.
Okay. So how would you get those? How do you get A, B, and C?
Oh, you factor it out.
Yeah, it is factored out.
Oh,
I think you mean you multiply it out.
Yes.
Okay. So we were going to multiply it out, and we got x squared plus 4x plus 2x. Put that together, plus 6x plus 8. Who already had that? Raise your hand if you did. Okay, good. Now what? Well, we don't really need to refactor it. It's already factored above it, so you should be able to tell me the roots. You already should have them. You got a couple roots, which are the same as x-intercepts, so you could put them like 0, comma something. Or you could even say x equals this and x equals that. I'd be fine with parentheses, something, comma, you know, saying them that way. You should be able to get the roots. You should have A, B, and C already. I can see them. They're on the screen. And then the vertex, I'll need to go negative b, which is a 6. That kind of looks like a b. That's a 6 because it was 4x and 2x put together, you know. Here, I'm going to make that more clearly a 6. Okay. You should use that when you're doing this vertex here. All right, I'd like you to compare your answers. I'm going to give you about 1 more minute to clean them up. Figure out A, B, C, what the roots are and what the vertex is. And I know the only hard part up there really is the vertex. Take some time, figure it out, or we'll have the kid next to you show you how to do it. Pause for a second. Let me figure that out. Okay, so let's go back and let's see. You know what? I'll take a volunteer. What's A, B, and C? Raise your hand if you're comfortable with telling me A, B, and C. Or Sean, what do you say?
A is 1,
Yep.
B is 6,
Yep.
and C is 8.
Very nice. Okay. The roots. Yes. -2 and -4. Because they're the things that make it equal 0. That's sometimes the way we call them, the zeros. Okay, cool. And could you have written them like this? Yeah, the x-intercepts are where y equals 0. So it would have been -2, comma 0 and -4, comma 0. You didn't have to write them that way. And last but not least, the vertex. Jack Pete.
-3, comma -1.
How'd you get the -3?
I got the negative.
It was negative b over 2a, so
6 divided by 2.
divided by 2 times 1. And that's -3. Cool. So -3, comma, and then how'd you get the other part? Hardest part of them all. How'd you do it?
I put -3 into the original equation.
So basically f of -3.
So I got 9 minus 18.
Some kid out there is going to put it here. Is that okay, Jack? For them to put the -3 in there
Yeah,
and there?
that's right. I put.
Okay, cool. What'd you get?
I got -1.
Negative, negative what?
-1.
-1. Can anybody verify -1 for the y part of it? All right. So that's the hardest part. How'd you get it? You stuck this answer into the function, and then that's right here. Okay? So you just stick the number in the function. But could you have stuck it in this function? Yup. It would have been totally fine to stick it there and there. You get the same answer, which was -1. So final answer, -3, comma -1 is the vertex. Okay. Now let's deal about it with a special case of a parabola, and that's when a parabola is thrown upside down like this. If you throw a ball in the air, do you get that it goes up and then it comes back down again? Do you get how a parabola goes up and then comes back down again? So this is the height, and this is time. Height and time. What's this?
Vertex.
Vertex. What's the equation for it? You already forgot? Negative b over 2a. It's the beginning and the end of the quadratic formula. That's technically that's the x of the vertex, and then the y of it would be f of that. Okay. Do you get when I did this parabola, I did not start at 0, 0, because if it's a ball that's going to be thrown in the air, does the ball start on the ground? No, it's starting in your hand. It's up above the ground. Okay, so that's this. Whatever that height is. For some people it's shorter, for some people it's taller. Do you get that this is the time that the ball is in the air? That right there. That's the time that the ball's in the air. What letter is that, X or Y? So your X is your time that the ball is in the air. At time 0, do you get the ball is off the ground because you're about to throw it, but you haven't yet? At time 0, do you get how it's off the ground? Makes sense. And then you throw it and the ball goes up to its highest height. And then it comes back down again and hits the ground at that time. All right, so at that moment right there, you have x equals negative b plus or minus square root b squared minus 4ac all over 2a. That's how you get the x-intercepts of a parabola, right? X-intercepts are the same as the roots, the same as the zeros. Do you think in the real world the numbers that you get actually are factorable? So you can factor it, you should, but immediately you go to, you're not going to be able to factor it in the real world. So you got to use this. And what's x again?
Time.
Number of pickles? X is the time, okay? And what's b and a and c? Well, those are those numbers in the front of a parabola, and so I need to talk those through with you. In the context of a ball being thrown in the air, everybody write this down, it'll be important. Ax squared plus bx plus c, that right there is the gravitational constant, and then we're going to say it's negative 4.9. Why? Well, because technically it's the gravitational constant, but then divided by 2, and we're going to do it in meters, and it's a whole bunch of work to get that number, but we can just start with negative 4.9 as long as we know it's meters, and as long as you understand it's been rounded a little bit. Okay, so that'll always be negative 4.9. Why? Because we're on Earth, and Earth has a certain gravity, and so you can predict that, and so that number is given. It's just given. Do you get if I went to Mars, gravity's different? And so that number would change if we were on Mars, but it'll always be the same on Earth. All right, why is it negative also? Because it's an upside down parabola, right? Don't we need a negative number in the front of a parabola to make it go upside down? Okay, all right, next. This is the velocity. That's how fast you throw it. Do you think anybody in here has perfect enough control to throw the ball at a certain velocity? Like if I say, everybody throw it at 2 meters per second, you think anybody could actually do that? I'm doubting anybody could hit exactly 2 meters per second. I mean like exactly that. I'm sure somebody could throw it 2 meters per second. What I mean is, could they like control themselves enough to do that? Probably not. Yeah, not likely to say, okay, now everybody throw it 3 meters per second. Nobody's going to know how to throw it fast to throw that. Okay, so that velocity is something we're going to have to calculate. We're never going to be able to control that and throw it at exactly this speed. How about this? What's that? Yes?
Height it started at?
Yes. Initial height. Could we control that?
Yeah.
Yep. It's actually kind of a pain to control, though, because if you're actually physically throwing the ball, you'd have to release the ball at an exact height. So let's say you wanted it to be 5 feet off the ground. You'd have to try to control your hand to let it go at exactly 5 feet, which is really going to be kind of hard. So we will figure out our initial height from you throwing the ball up in the air. You're going to just let the ball go. And if you're confident about throwing overhand, totally okay. But it's kind of hard because you got to throw it straight up. It's not easy to do. You're trying to throw straight up. Okay? Or you can throw underhand, and then it's easier to throw straight up. Okay? So somebody's going to be videotaping you as you throw the ball up. Ball's going to leave your hand. And we'll be able to figure out this velocity because we will know the starting height, gravity, and one more thing. What's y? Yes. Y is not time, by the way. What's y?
The apex, the vertex.
Nope. Y is not the vertex. Thank you for trying. Yes?
Why is the height?
Y is the height. And you might be like, but you don't know the height. I know the height at 2 times. I know exactly the height that you let it go at. If I can look at the video of you, I can know what height you were at when you let it go. And when's the other time I know the height? When it hits the ground. Those are the 2 moments that I know the exact height. I don't know the velocity, but I can figure it out. I also know the initial height. That's the starting height. That's when you release the ball. Now, just to keep our life simple, we could do some complicated stuff to try to figure out exactly where did you release the ball, okay? But I'm going to allow us to just say that most kids are going to release it pretty close to like here-ish, which is above your head, which is in the neighborhood of 2 meters, and it's a nice round number, so we're going to say 2 meters. Okay, and I know, it might be off a few inches. Could that affect everything? Yeah. If you want to be more accurate than that, I welcome you to be more accurate than that. That's cool. But I'm allowing you to keep your life a lot simpler and say that your starting height will be about 2 meters. I've had some kids say, can I have my starting height be on the ground? No, because you can't really release the ball from the ground. You know what I mean? Like, now, if you were to kick the ball, that'd be different. But then kicking the ball straight up from the ground, it's really hard. You know what I mean? So having the starting height on the ground is really difficult to actually get any upward motion. All right, remember I said straight up. Why? Because we have no control of left and right in this. We only have control of the height and the time. So we're going to be just figuring out the vertical velocity. Do you get in the real world when you throw a football to your friend? There's an element of up, and there's also an element of over. That can be handled with different equations, for instance, like parametric equations. And some of you guys are in physics. Anybody in physics right now? There's usually at least one kid. Nobody. Okay. Well, in physics, there's a special equation you can use that involves the lateral and the vertical. So like up and the over. And it's a more complicated and better equation than this. But we're trying to keep it simple. It's just one quadratic equation. So we need to just control that we're only throwing it up. Totally forgiven if you go off a little bit and it goes a little bit left or right. You don't have to like make it hit you on the top of the head. Just, try to throw it straight up. Close as you can. Okay. So, what is a typical homework question? Well, we've covered a lot of things here. Let's go through these pretty quick. This tennis ball lab, I've already talked you through it, really. I just haven't actually helped you figure out how to find exactly what the time is when the ball hits the ground. And now it's talking about throwing it off of a roof, and then the roof height is this. We're not going to go up on the roof, okay? But they're saying, we want you to tweak the lab to say, what if you had thrown it from the roof? Then think about it. Wouldn't the ball be in the air a little longer because it would have to go all the way down if it goes down to the parking lot from the roof, okay? I know there's elements that are an issue here because if you truly threw it straight up, it would come back down on the roof. Then it wouldn't matter. But if you threw it up and then it went down into the parking lot, that does add a complication. Okay, so let's not worry about that right now. Let's worry mostly about find the max height of the ball that you threw. You can figure out the height just from the time? Yep. And that is the whole challenge of the lab. And if I tell you just do this, I've already kind of told you during the course of this, but I'm not going to come out and just say, all you got to do is take this equation and put this in and this in and this in and solve it. Okay? But if you understand this well enough, eventually you'll figure out, I could just put this and this and this in the equation and solve it. Okay, so we need to get the raw data. So here's, in a moment, not right now, soon, we're going to go outside and we're going to throw the ball up. You're going to find somebody to record you and then you can record them. This is not a partner for life. It's not even a partner for the lab. It's just to record the stuff. Okay, and you're doing your own lab. All right. We'll use the format for all labs. It's right here. It's got to have a purpose. It's got to have a sketch. And it doesn't have to be a beautiful drawing of you throwing the ball in the air. This is more like the parabola, you know? It's got to have a procedure part where you explain in words, describe the actions. And then the calculations part where you actually, this is where you're going to grind out your equations. You're going to get some numbers and you're going to solve equations and then you'll get your velocity. Oh, wait, that's the other thing is, we'll figure out how high the thing went because that's the vertex, right? And we'll also figure out how fast the ball was going. That's the velocity. All right. And then at the end, you'll put your conclusion in the conclusion, right? And then you'll reflect on it and say, here's some things I learned about math. And you can reflect on how we can make the lab better. All right, so this is just a review about absolute values. Remember that the absolute value on the outside makes the stuff on the that's underneath, you know, kind of like flip up like this. Remember that? Absolute values on the outside? Okay. So find the following, the vertex. Ooh, I know how to do that. Do you know how to do that? It's 5, 13. Boom, I'm done. See where I got that from? Do you remember when they're in this format? It's that simple. Did I have to do negative b over 2a? Nope. What if I had? I'd get the same answer. It would just take me 10 times longer. Do you get this part is x equals negative b over 2a? But you'd have to multiply this thing all the way out, and it'd be a really dumb because the vertex is just sitting right here. Why didn't I use negative 5, Teddy? Don't trust the inside. Very good. And he used positive 13, so yay. And how about its domain and range? Well, if it's an upside down parabola, it's looking like this. Do you get all I really need is the highest height it went? Otherwise, the domain of parabolas is always both directions. It's always all reals. Parabolas' domains are always all reals. So then the height is just the issue. And if you're throwing a ball up and down, there's usually a limited height, right? It makes its peak at the vertex. So really the range would have to do with the vertex. All right. Actually, you could have finished that one. The highest it went was 13, so you should have said negative infinity to 13 would be the range. All right. The last thing I need to teach you is called complete the square. And I'm looking at the time. I think I can do it. And I think it's important enough that I should stop and complete the square. Because why? Because it helps you find the vertex form. And I know your brains are probably like nearly full. Make room for one last thing. Okay? Do you get if this right here was like this, x squared plus 8x plus, let me think. And I have a little trick for this. I make it half of 8, and then I square it, and I make that 16. If I make this a 16, then this would have been a perfect square. Do you get what just happened there? But you might be like, but there was a 1 there. There wasn't a 16 there. But if there had been a 16 there, do you get it would have worked out pretty dang nice? it would have come out to this. Why is that good? Because I know the vertex of it. The vertex at negative 4, 0. Put a plus 0 here if it makes you feel better. And you don't trust the inside. All right? Okay, so how'd you get that 16? I said instead of using this, I want to use half of this and then square it. Half and square. Half of 8 is 4. 4 squared, 16. Fundamentally, that's what you do. But the problem is, you can't just like act like this is a 16. So, here's what you do. You know you want it to be a 16. And so you go, okay, well, what I could do is I could just move this 1 over. Give me just a second to erase a little bit more here. I could move this 1 over here. I'm just moving it over. 15-minute warning. I'm going to move the 1 over here. And then I'm going to do the number I wish it was, which is 16. But I'm not forgetting about the 1. Now, would you agree that I can add 16 on this side as long as I subtract 16 on this side? But wait. Wait a minute. I'd have to add 16 on both sides, right? If I added 16 to both sides, I can do that, right? But there's this faster way that you've never done before. If you add 16 and then immediately subtract 16, you can do that. Yes?
Wouldn't be adding 15 and subtracting?
Nope. We moved the 1 over. Remember that 1 that was here? We moved it over here. This is the magic number. I want that to be a 16. Now how I want that to be a 16? Because I want it to be half of this and then squared. The 1 is still over there. It's just moved over. So now this part factors to x plus 4 and x plus 4. And this part tells me what the last number is. What's the negative 16 plus the 1? Negative 15. And that's really x plus 4 squared minus 15. Minus 15. And that tells me my vertex. My vertex would be negative 4, negative 15. I did what's called complete the square. And I found the vertex. All right. We are not going to do more complicated ones right now. I think if you wait on your question until I do one more, I think you'll understand it better. Everybody write this one down. X squared plus 4x plus 2. Is that a perfect square? No. The way I can tell is if I go half of 4 and then square it. What would have been perfect would have been, what is half of 4? 2, and then square it. I wish there had been a 4 right there, so I put a 4 right there. Wishes can come true. But then, because I added 4, I got to immediately subtract 4. And don't forget that there was actually a 2 there. It comes in at the end. This part's the perfect square. And you could put 2x plus 2's, but I'm just going to pay x plus 2 squared. And this part is my minus 2 at the end. Holy cow, that was a lot. All right. So we're going to stay here. We're not going to actually go outside and throw the ball today. We'll do that tomorrow. So everybody is about 2/3 of you that don't have warm clothing on. So we'll just go out there tomorrow. Bring a sweatshirt. Make yourself a little note. You have a smartwatch. Tell it to remind you to wear a coat tomorrow. The first hour. Or whatever hour of math you're going to be in if you're listening to the video. All right, let's just do one more of these. And why did I do that? Because I know the vertex now. It's -2, -2. That's pretty quick to find the vertex. Could I have done -b over 2a? Yup. That works too, but that's really slow, painful. All right, one last one. Y equals x squared plus 10x minus 1. Is that a perfect square? No. So we're doing a process called complete the square, where we say, I wish it wouldn't have been a 10x, or sorry, wouldn't have been a -1. I wish it would have been this magic number. And whatever that magic number is, then we're going to subtract that magic number, and then we're going to try to remember to bring this into the final answer. All right, do it. Talk to the kid next to you about what should go on each line. If you have to, show them how it works. Pausing for a second, I give that a shot. Okay, let's see if you understood.
Oh, we're doing.
Half of 10 is 5, 5 squared. Who all put a 25 right there? Raise your hand if you did. Okay, good. And then a minus 25 there because it cancels it back out again. Could we have added 25 to both sides? Yeah, but this keeps it all on one side and it's simpler. Then this part factors, x plus 5 quantity squared. And this part makes -26. Vertex is then clear and easy. -5, -26. Do you feel like you get how to do complete the square now? Okay. And then what if I'd have said, hey, do complete the square with the other way? X equals -b over 2a. Just in 2 seconds, figure out the x of it. Some of you are going to say, I like this way better. -10 over 2 times 1. -10 over 2, which is -5. Cool. What's the only hard part then? How do you get the y of it? What do you do with the -5? You plug it in. The -5 could be plugged in there and there, and then you could have got your y value from that. So some of you will like this way better, and some of you would rather find a -b over 2a and do it that way. All right. So there's your A, your B, and your C of the quadratic formula. The little review part here now. Remember that we found the vertex is -b over 2a and f of -b over 2a. Here is our quadratic formula. I said this part was mostly important if that, which is called the discriminant, is ever less than 0. Because if the discriminant is less than 0, there's no solution. If the discriminant is ever, I call it D, is ever bigger than 0, you get 2 solutions. And if the discriminant is equal to 0, then this whole part drops out and you have the vertex, which obviously if it's a vertex, there's only one of them, one solution. Okay, so here's your 3 things. See if you learned it. What if the b squared minus 4ac is less than 0? What is it? What is it and what is it? Okay, I'll get volunteers. What happens if this is less than 0? Raise your hand if you feel like you can do it. Yes. What if it's negative? What if b squared minus 4ac is negative?
Because it's in the square root, that makes an imaginary. So
Yeah, there'll be the square root of that, and then there's, how would you say the answer then? No real solutions. You did make a good point that technically you could say there's imaginary solutions. What if the discriminant's equal to 0? Yes.
One solution, which is vertex.
Yes. The advanced answer, it's the vertex. Okay? And Jack P., the last one. What if there's a positive discriminant?
Two solutions.
2 solutions. SOLN is a good abbreviation for solution. Okay. This is just reminding you it's a relative minimum, also known as an absolute minimum, and a local minimum. This is just reminding you that if it's in this form, you got your vertex right here, but you can't use negative h. You always don't trust the inside, right? So it would be h comma k would be your vertex. But we talked about that in the context of real problems. All right, thank you very much. You know those other worksheets that you mentioned you printed off this
Yeah.
morning? Where did those go?
You know, I just printed them. I wonder if somebody accidentally took them.
I bet they might have. Maybe they're by the printer.
I'll double check.
Okay, and if
If
they're,
not, I'll just reprint it.
that'd be great. Yes,
Great.
thank you very much.
You're welcome.
Okay, so this one's a word problem, and it's just like a parabola, except given the real world. Guess what's important? The x-intercepts and the vertex. Because if this is about profit, do you get that the maximum, the highest profit, is probably something interesting to the company? Okay. And then this is where the homework would start. I'd recommend you do this one. Man, this is a great review of almost everything. This one? Sure, but what's more complicated about it? It's got a number in the front. That's going to make it more difficult. Could I still do it? Yup. Could I see that being on a test? Yup. But you'd have to give the answers using the quadratic formula. This one's worth doing because we're not promising to make them always factor. I did say they often factor. That sort of leaves open the option for not always. All right. I think on this assignment, I would skip this one. This one's a lot like the lab. I'd definitely do it. And this one I would not do unless you have lots of time and want a challenge. So what do we know about our time? Do you get in the real world, you often start your experiments at time 0? And then, in fact, if you ever see a countdown for a rocket, they go T minus 10. That means minus 10 means 10 seconds before liftoff. T minus 9, T minus 8, 7, 6, 5, 4, 3, T minus 2, T minus 1. It's like 1 second before liftoff. And then at 0, liftoff. And then what happens at 20? Well, the thing probably came back down, hit the ground. Most rockets don't stay up. They go up and they come back down. There's a few that stay up there. They get escape velocity and they get out into orbit. Okay. For these, I wasn't even expecting them to be there. Probably too intense. But I've seen stuff like this on the ACT before. I think I'd do this one. Because they're seeing if you know how to use the discriminant. B squared minus 4AC, you know? And then these are always good, clean, simple problems that oftentimes are things you would find in the HL version of the class. Next year, you're going to have 2 options, AP and HL. And there are 2 different ways to take calculus. So, do you have to do it? I can't make you do anything. But I think it'd be worth trying one of these. Whenever it says required, that as opposed to like challenger, which means, yeah, don't bother. Okay, that's all I got for you for today. Have a good day.